There you are. We can see your presentation.
Perfect. So just yes, it started. So I can just begin. So hi everyone. My name is Raghild Høvik and I work for Grieg Maritime Group. And I just wanted to start the presentation today. I've been asked to tell you about what we are working on related to green ammonia in our group. And we have several exciting projects, which I will get to. So just to give you some background information on who we are. So we have a long history within shipping. We own and operate a large fleet of vessels sailing across the world today, so-called deep sea vessels in the open hatch segment. And we have a joint venture with another company, Bulk, that is called GT Ocean. So they have the commercial operations on the world's largest open hatch fleet. And then we also, all of this is done by Grieg Star. And we also have a company, Grieg Green, that was established in 2010, where we offer services within green or sustainable ship and rig recycling. And then in 2020, we started the company Grieg Edge, where we focus on maritime solutions in the green shift. And this is a step from our core business to trying to find new solutions in the maritime green shift. So in Grieg Edge, we focus on 4 segments, and short sea, offshore wind, and energy and infrastructure. Then we develop projects on our own and together, and mostly together with partners. And the last one, Ocean Ventures, we invest in typically startups that are relevant or have solutions or related to the green shift. An example is Ocean Oasis, which are developing are using wave energy to desalinate water and supply fresh water to shore. But today I'm going to focus on what we do in energy and infrastructure. And in shipping, when we say we will be zero emission or carbon neutral in the future, we focus on 3 main aspects. So the first we do to reduce our carbon footprint is to optimize our ship operations. That means that we look at the logistics side, how the vessels are operated. We look at the sizes, the fleet sizes, and also the ship sizes, and see what we can do to increase the utilization of each vessel. And next thing is looking at how the energy efficiency of each vessel is, and technology we can use to reduce the energy consumption. So we look at different technologies related to the engine side to reduce or improve the performance of the engine. We look at typically sails and also other technologies for reducing friction in the water, such as the air lubrication. So all of these technologies are very relevant to make the vessels more efficient, and then we also reduce our carbon footprint. And then lastly, green fuel is needed in order to get to zero in the future. And we believe in a mix of fuels in the future. We look at biofuels, we look at the different e-fuels or electrofuels, but we also see and I started several projects related to green ammonia, because we believe that it will be a very good and viable fuel of the future. So why are we looking at green ammonia? First of all, it's carbon free, and looking at the well to wake perspective, today we have to report our emissions considering a tank to wake perspective. In the future, we will probably, most likely, looking at what IMO is doing right now, report our well to wake emissions. That means that the entire life cycle of the fuel we're using will matter on our emissions. And the green ammonia is produced from renewable energy and has very small well-to-bake carbon and greenhouse gas emissions. When also looking at carbon-free fuels, carbon-free, you basically only have ammonia and hydrogen. You have a higher volumetric energy density with ammonia, which means that you need to allocate less space on board on the vessel for the same energy content, which is very important for us in most cases. You hope to utilize as much as possible space to cargo and as less, at least amount of space to fuel. And also looking at the electrofuels, those that are coming from renewable energy and through electrolysis from hydrogen. Ammonia is the fuel that requires least energy. And I will get a little bit back to this point, looking at the production side. And that also leads that we believe that we can have a cost-effective production of green ammonia, especially looking at the development, at the expected development in electrolyzing technology in the future, or in the coming years. And lastly, we look at the long experience that the shipping has, or the world has, in the handling of ammonia. It is traded as a commodity today, and many vessels are carrying it, and it's handled in ports and transferred. And we need to look at this experience and competence and the safety, especially the safety mechanism that they are applying when we are going to apply this as fuel on vessels. And as probably all of you are quite aware of, ammonia is quite toxic and can be fatal if you get a spill, and there are typically crew in close by. And so the safety is our first priority when developing all these projects. We need to make all our projects that we are developing need to be safe for the people that will work with them and also the environment. And so just to explain where do we get ammonia from, or the green ammonia. And you start with green hydrogen that you produce from the energies from renewable energy, typically wind or solar. And you need an electrolyzer to produce the hydrogen. And it's important to note that this is a part of all electrofuels. So if you have e-ammonia, e-LNG, e-methanol, or even e-diesel, this is the first, this is a part of it. And there is a high energy loss related to producing hydrogen from renewable energy. You lose approximately 50% of the energy when producing hydrogen. And that, of course, is a downside when using these new electrofuels. And we hope that we can improve the efficiency, or the technology developing, and there will be an improved efficiency. But we need to be aware of this loss when going forward and evaluating the different fuels. And that's why also it's important to be aware of the energy intensity of the different fuels. And this graph shows the energy input versus output you need for the different e-fuels, and where you see that ammonia is the best option for that in that case. So that's one of the main reasons why we are looking at this. Going for the whole value chain, from hydrogen, you need to also add nitrogen through a Haber-Bosch synthesis process, and then you need to transport the ammonia on board the vessel and use it then for propulsion. And of course, most engines on vessels today are not as efficient as we would like, probably, and there is also a loss in energy when using it on board vessels. So that's something we need to be aware of. But we still believe that ammonia is a promising fuel for shipping, especially when we need to reduce our carbon footprint going forward. Looking at 2030 going over to 2050, we aim to be climate neutral, and we believe that ammonia is one of the viable solutions to do that. And for our sake, it's the work with ammonia started with a collaboration called SEEDS. We were asked by a group of companies to look at how we can get zero emission solutions at sea. So together with Wärtsilä and Aker and several other companies, we looked at different solutions on how we can get to zero emission in the maritime industry. And ammonia was chosen as the first stepping stone. And we got funding from Pilot E together with Wärtsilä to develop an ammonia bunker vessel. So this vessel, which we call MS Green Ammonia, will distribute ammonia along the coast of Norway, both to terminals, and also it can supply directly by ship-to-ship bunkering. And our responsibility in Grieg is to develop the vessel concept, and Wärtsilä will develop the engine. So this engine is under development in Finland as we speak. And we have a close dialogue with the development team, and it's a good progress. So and also in the SEEDS collaboration, you have Aker and Varanger Kraft that are planning on or are developing a production facility of hydrogen and ammonia in Berlevåg, far north in Norway. So they have a large energy park wind energy park at Raghild, which is will supply the energy needed to produce the ammonia. And then our vessel will be able to come into Berlevåg and load ammonia and distribute along the coast. And we have a movie. I hope it will work. There we are. And looking at this specific project, we are still in the early phase, I would say. We are finalizing our concept design. And since we have no rules available or adopted by IMO yet, we need to use the alternative design approach, which means that we have to show by risk assessment that the design is safe. And there are several class societies that have developed rules, so we are working with the DNV, and the rules they have developed are giving us good guidance on the design. We are aiming for a vessel ready in late 2025, perhaps 2026. It's depending on how we see the commercial side developing, especially also the production projects. There are several projects ongoing on production of ammonia along the coast of Norway, and we want to align our timeline with these projects. And one of the major milestones we've done so far is, first of all, we did a hazard assessment. We're looking at the risk of everything that could go wrong when using ammonia as fuel, and we had 2 days of an interesting workshop together with very important partners such as LMG Marine, which is our ship designer. We had DNV as both the class and also experts on ammonia handling. We had NMA, as the Norwegian Maritime Authority, participating, and of course Wärtsilä on the engine side and also the cargo handling side. So there was a lot of competence, and we none of the hazards we found in the assessment was in the so-called red zone, non-acceptable risk. All of the hazards we found or identified we were able to close them further in the design, in the detailed engineering of the design, and also by developing operational procedures. And that led to receiving an approval in principle from Class Society DNV in April. So we have received a lot of good feedback and also a lot of attention related to this project that really gives a good momentum to work with further. And what the approval in principle will basically say that the concept design as of now is it is safe to use ammonia as fuel. And that's a really good foundation to continue working on it. So we are still working on developing the concept and working with our partners. So more of the details on the distribution vessel. You see the main dimensions in the corner. We will have the vessel will be able to develop ship to ship and also to terminals, and we aim to deliver a loading capacity of 1,000 cubic per hour and a total cargo capacity of 7,500 cubic. And the vessel will have 2 of the engines from Vadsø on board, and we'll also have a electrical distribution system and use MGO as pilot fuel, and then we are aiming to use as a bio MGO or biodiesel for pilot fuel to be fully zero emission. And the cargo handling side is semi-pressurized. We have 2 IMO Type C tanks on the vessel, and we are aiming at containing the vessel at fully refrigerated at -33 degrees and atmospheric pressure, and handling of the transfer operations will also be done at the same state. And that is for safety reasons. In case of any leakages, we want to limit the leakage as much as possible, and then we see that having it fully refrigerated is the best option. So this vessel, will be distributed along the coast of Norway and to the Skagerrak area. We also aim to deliver ammonia to Svalbard if they choose to use ammonia as energy source in the future. It is not yet decided, but the facility in Berlevåg in northern Norway is a good, ideally located for transferring the ammonia to Svalbard. So we hope for progress in that process. Yeah. But we're also working on several other projects related to ammonia. But these are located or for production. So it started with the MS Green Ammonia, trying to or aim to distribute ammonia, but we also see there's a need for production capacity. So we have a joint venture with Arendalsfoss Company in Arendal, south of Norway, where we have established a company called North Ammonia. So they will produce in phase 1, 100,000 tons of green ammonia from 26-27 using hydropower. And we also have several other projects that we are working on for production other places in Norway. We also have invested in a company called GreenH, which are focusing on production of compressed hydrogen and are looking at several locations in Norway. And we also have a agreement with Esso, North Ammonia, and GreenH regarding creating a maritime hub for green fuels in Slagentangen. Slagentangen is located near Åsgårdstrand in the Oslofjord, and it's an ideal location for distribution of green fuels to because there's a lot of maritime traffic going past Slagentangen. So this is a very exciting project. So we are working on establishing a whole value chain of green ammonia along the coast of Norway. And in addition, we have in our core business, Grieg Star, we are looking at the retrofit case for our current or newest design, which is already 10 years old actually. So we have the open vessels that you can see in the corner, where we are looking at using a retrofitting to ammonia on a transatlantic trade. So or a large part of this pilot study. It's a desktop study as of now. We are looking at the retrofit, of course, but we're also looking at the entire value chain. So we'll be able to get available green ammonia in Brazil, in the US, in Rotterdam for this vessel. So we have a lot of great partners that are working and contributing on this study. And we are planning to finalizing the study in December this year. So it's exciting. It's a really exciting project, and we're really seeing also the challenges with availability worldwide. So one thing is establishing an infrastructure in Norway. Another thing is to do it worldwide. So yeah, this was my presentation for today. But I'm not sure if